Okay, hello everyone. Um, I wanted to go ahead and start this a YouTube series to hold myself accountable. This will be the first day and the first video of this said series. This is preparation for interview season, which will be happening. Applications will be happening in August and July. Interviews probably gonna be happening August, September, October, and November, which you have, those kind of months. Mainly probably September and onwards, because, usually the first months are for behaviorals, but, I'd like to be readily prepared, if I could be. So, that includes doing some LeetCoding. Now, I have worked with majority of these, I believe. Or a little bit of everything, but it's been a little bit of time, probably about a little less than a year since I've last done some LeetCoding. So obviously I'm going to have to retouch up on that to kind of figure that out, clean that up. As I would like to be readily prepared for whenever interview seasons actually comes to pass. So today is the May 26th, 2025, and yeah, I'm going to go ahead and start up. I was thinking of starting off with NeetCode, just to kind of get like a roadmap of like maybe what I should be looking into. So I have a roadmap here of just, the classic stuff, big topic ideas. And then there's also this on NeetCode as well, which is really cool. Implementing data structures. I'd probably be pretty bad at this. It's been a little bit of time since I've done something like this. Might need. I wonder if I have to program this in C++ probably. I mean, I could definitely do it in Python, but I feel like it might be more redundant in Python. Sorting. I do remember a small amount of my sorts. Maybe not insertion sort. It's been a very long time since I've touched insertion sort. Matrix. Okay, graphs. Yep. A little bit. Probably needs some more time. Dynamic programming. Yeah, for sure. Need some more time on that. Design patterns. Yeah, I've actually never touched this. It says easy though. I don't know if this is kind of a thing where it's just like something you kind of do without noticing. Like object-oriented programming. A lot of people do the 4 pillars of OOP without even knowing it. And so whenever it comes time to ask about OOP, a lot of times they're almost confused how to explain it because to them it just is kind of secondhand nature. And then machine learning. Haven't touched that, and I don't think I would really need to. Mainly because I don't think I'll be applying to any machine learning stuff. I don't have much machine learning experience at all, and I feel like I'd be very underprepared to apply to something machine learning for full time, unless if the new grad position is very lenient and open to people who are willing to learn. But I don't know. Never done a full-time job before, right? So I wouldn't really know for sure. But yeah, I'm gonna go ahead and I'm gonna start us off with array and hashing. So I might not be that good at this. So I will patiently ask that if I am making lots of mistakes, please please don't be mean. Okay. So, can I go to the actual LeetCode page? I want to kind of solve this on LeetCode. LeetCode contains duplicates, so oh yeah, and then I also want to use this page as well to draw all my solutions. Okay. So given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So, if true, the element 1 occurs at the intersection of 3. Okay. Alright, so I don't think I really need to be drawing this out, but for the sake of consistency, I will. I guess, well, hold on. Ah, there it is. Oh, I purchased a drawing tablet, so that way I can kind of like take some notes. Oh no, all the cords got tangled. That is unfortunate. Oh, my days, there's so many cords all over the place. Okay, alright. Fixed it. Now I just need to plug my Wacom back in. So, this problem is fairly simple. It isn't easy, right? As you can read it, you see that, but the cutoff is bothering me. Why is it cutting off right there? Yikes. Yeah, this problem's fairly simple. Actually, you know what? Let's not do 2 pages, because let's just do 1. And let's just draw on a separate one. Okay, so let's look into it and explain it. You have a list of all these items, and we want to keep the search low, and then also the we want to keep the space low as well if we can. So something to take note of, we're looking for how many characters actually occur, or how many times the character occurs. So if you are going through this array and you see 1 happen more than once, as you do here, you'll count it 1, 2. So that's how your brain will process it. So for a computer, it's not necessarily going to automatically see that. Instead, it's going to have to linearly pass and go through it, and then do kind of a check on it. So what's a great way to keep a counter going for each item would be a dictionary. A dictionary, if you don't know, is a key pair value, so it'll hold a key. So in this instance, the 1 will be the key, and pair will be the number of times 1 happens. Or sorry, is it key or is it index key? I always forget the terminology, but basically something is the key, and then when you access the key, you'll get a value that's connected to it. So in this instance, we would make a dictionary that the keys are the actual character. So yes, these are numbers, but we're going to ignore that, and we're going to just treat it as like a variable that could be anything. And then the actual value that is connected to that key will be how many times it's there. So what we can do is we can say on update, check if it's getting if it's going to be bigger than 1, and if that is true, that means there's more elements, more characters of that letter number than 1, which means there's more than 1, right? Which causes duplicates, and we don't want that. So that is how we're going to check it. And I think, yeah, I'll go ahead and I'll draw this out. I'll try to be quick about this. If not, you can probably just skip ahead in the video since I already talked about it. I'm assuming if anyone's probably watching this is probably just common sense to some people. So they probably don't even care. So we'll say 217 contains duplicate. So we have, man, I kind of don't want to write this one out. This one, I feel like this one is just self-explanatory. Maybe I'll just type this one out. We will loop through an array. Each time we hit the arrive at a new index, we will increment the counter for the character at the index. Our counter will be a dictionary. On update, we will check. Whoops, sorry. On update, we will check to see if the counter is greater than 0. If it is, then we fail the array specifying that an index exists. Wait, hold on, let me read the problem again. Is it just true or false? Okay, cool. I don't have to return anything. Sorry, an index? Whoop. A duplicate exists. And then, yep. If we reach the end of the array without ever without ever finding a character with occurrences greater than 1, then there are no duplicates. I spelled occurrences wrong. Occurrences, and I spelled dictionary wrong. But dictionary. Okay, so talked about it, kind of mentioned it. Oh, let's do time complexity. So time complexity here is actually going to be pretty easy. It's going to be O of n. So the reason why is we're going to be linearly passing through an array. So each time you pass through, that's going to be n characters. So it's up to n. You could do it without the n. So, so say n, or let me, O of n time. Or can I just put TC? I feel like that should be easier. TC. Yeah, I always write kind of diagonally. So it is going to be O of, man, my O's are looking horrible. O of n to pass through array. Right, we're just going to be linearly passing through. So the where n is going to be the number of elements inside the array. So O of n to pass through the array, and then it's also. So what are we doing? We're passing through the array, and then we're going to be updating and checking the dictionary, and that is O of 1. O of 1 to update and check dictionary. Okay, so dictionaries have nice speed, very nice. Okay, so let's go ahead and run this real quick. I'm going to type this out, so make this pretty easy. I'm going to go say for index in nums. And then I want to make up here, sorry, make my dictionary. I'm trying to remember my Python. Just gonna call it Python syntax. Yeah. So I'm gonna call this. There's a special word I wanted to use. Occurrences. Character. I'm gonna do camel case or character occurrences. Right? Is that the one I want to do? I think so. Dictionaries represent my code races, and this IDE is upsetting me. I don't I don't like the way this looks. So I'm gonna say yeah. So first of all, nothing's inside the array or the dictionary. So let me right here say a dictionary for the number of man, I can't type. Of occurrences per character in the array. Okay, and I'm gonna say if index in if index in character occurrences, then we kind of just fail it. Is that how you do this in Python? I can't recall. Is Python capital F or lowercase f? It's capital F. Okay, so I'm getting some syntax here. Else, I'm going to say the reason why, okay, so basically if the index is inside the character occurrences, that means, you know, that means it's already been inserted. So if it's been inserted once, that means our dictionary has spotted its existence. So if it's not inside of it, then we're going to do character occurrences. I'm going to say of index is equal to 0. Oops, yeah. Sorry, I've been coding in C# a lot recently. Actually, it's been a little bit about like 2 weeks since I've programmed. So apologies for that. But yeah, this is O1 and this is O1. And then if we end and there's nothing to happen, then we're good. Oh, I'm not even logged in. Let me log in. Okay, awesome. So just fix a bunch of stuff. Sorry, I had to go make an account. My account was not working. Alright, let's just check it, see if this runs. If this doesn't run, then... Oh. Wait. Oh, return true. Let's get this incorrect. True. Whoopsies. False. So yeah, this is true that it does contain a duplicate. Okay, and then I'll submit it. And nice. So there I am on the faster side, just left-hand side, slower of the bell curve, but it's okay. So that was 217. Contains duplicate. So say 217 contains duplicate. How many pages am I limited to? Oof, I got many. Can I just click backspace? No. It's probably too many. Too much to delete on one. So I want to do another one. Do I need to make an account for Netcode? Because how it's gonna check my thing. I do have an account. He'll peek. Let's go. All right. Done. Let's do one more. 7:58. So I don't want to make this video too long. I'm just gonna do 2 today. 2 easies. Probably do more another day. A valid anagram. It's valid anagram. So let me look this up online. Sorry. Okay, here it is, valid anagram. 242 valid anagram. Let me go ahead and... Oh, come on, don't be mean to me. I literally just highlighted you a second ago. Can I copy that, or is that gonna be like one of those kind of... Ah, beautiful. I'm gonna put this in text. I'm feeling a little lazy, so we're gonna say 58. Say 242 valid anagram. And we're gonna fix this block sizing to that. Okay, it's not stuck at 58. It is. No, I think it was 12 before, so we're gonna go back to 12. I don't know what's gonna save it. Probably not. So, given two strings, string S and string T, return true if T is an anagram of S and false otherwise. So, what is an anagram? An anagram is a word or phrase formed by rearranging the letters of different words or phrases using all the original letters exactly once. Okay. So there's a couple ways you could solve this. So earlier we did... so this is hashing. Yeah, interesting. So this wants you to, hash your... using a dictionary. So you could do this hashing. You could do this also sorting as well. So basically, we need to make sure everything has the exact letter occurrence per time. So if T shows up 3 times, it needs to show up 3 times in the other string. One way you can do this is a dictionary, and then I guess you could technically loop through said dictionary to kind of check that. So I'm trying to think. There's a couple ways you can do this, or you could do sorting. Sorting works. So the problem with sorting is sorting at the fastest has like n log n time complexity, which is not bad per se. So with sorting, what you can do is you can do an n log n time complexity, and then you can do an O of n linear pass to basically check each side, which is not bad. With dictionary control, I could go do a linear pass through both of them, which is O of n, and then I could throw that into a dictionary, and I could probably keep that going. I could technically maybe do linear pass with dictionary, although I don't think that's really a wise idea. I'm trying to think. How I would efficiently do that. I would probably do linear pass through the first one, S. Then I would store that into the dictionary. And then what I would do is I would go ahead and do a linear pass through the second one. Oh, sorry, hold up. I guess it didn't really make sense when I was explaining it. I would go through the first string, and I would store the number of occurrences per character in the dictionary, using similar to what we did the last problem. So I would be doing addition per pass. And then on the second string T, I would then decrease the number of occurrences. So if T appeared 3 times, and then I just hit index T, then I would say dictionary -1, right, of that position, and so the 3 would be then turned to a 2. And so then what you can do at the very end, once you do your linear pass through both of your strings, you can then check to see. So if the dictionary, if you do like a pass to the dictionary and everything inside the dictionary is 0, then you're good. That means it's an anagram. If it's anything other than 0, then that's bad. So this requires 3 linear passes, which is O of n times 3. So in terms of scale, this would scale a lot better than a search. This does have man, I don't know the exact space complexity of like how dictionaries work, because it's kind of like a key value pair, but I'm going to say O of n, because it scales up to the size of the index. It might be a little bit kind of different because it's not like an array, but I'm going to say O of n. As compared to inline sorting, if you did inline sorting and then compared it, the space complexity will be nothing. It'll be zilch pretty much, because you're not going to be adding any space. You're just sorting. Unless, well, if you're doing specific inline sorting, it'll be zilch, right? I believe so. I could be incorrect on that. the space complexity would be whatever it is on the sorting part. Anyways, that's enough yap for that. Let's write that down. Or type it out, because I don't really feel like writing. I got this writing thing. I'm not even going to use it. Let's go a little bit bigger. Let's do 15. So, valid anagram. We want to check to see if two separate strings are, man, I can't spell for the life of me, anagrams of each other, and that is why I am not an English major or journalism major. Yeah, speech is difficult. Separate strings are anagrams of each other. So how we would go about that? We're going to take a O of n TC time complexity approach where we will linearly pass through the first string. We will have a dictionary that stores the number of occurrences per character. Then we will linearly pass through the second string. We will de-increment or decrease the value in the dictionary instead of increasing it. Okay. If afterwards we will linearly pass through the dictionary to see if each value is 0. And then here is my reasons. The dictionary holds the number of occurrences. If we say if we increase on the first string and decrease on the second string, then in order for them to be anagrams of each other, they must cancel out. And I'll put an example. Example 5 minus 5 is equal to 0, meaning it canceled out, right? So if every character cancels out appropriately, then every key value will be 0. And let's go ahead and just fix all these horrible spelling mistakes on my part. Okay. And yeah, this is O of n, time complexity. So let's work it out. Okay. I'm gonna do character occurrences equals to an empty dictionary, and I'm gonna say for index and s, I don't like that naming convention, for index and s, if s in character occurrences then we're going to say that character occurrences of s plus equals 1, right? We're basically adding that. Else, so if it doesn't exist, then we're going to say character occurrences of s is equal, to 1. Okay, or is 1, apologies. Okay, that linear passes through the first one, and then for index in t, if t is in the character, what am I saying? I'm rotting right now. If index is not in character occurrences, so if it's not in character occurrences, this is bad. That automatically off rip is kind of like we could just automatically just return false here. It's not an anagram. That means there's an extra character. So the word dog and god are anagrams of each other. So basically, if you said like gaudy, right, or whatever, if you added a y to the end of god, then you could say that, hey, that y doesn't exist inside dog. There's an extra character, which is what this would check for. And now if that's the case, we'll return false. We want this edge case so that way we don't accidentally kind of error out. I mean, this is Python, so it's going to kind of take care of that for us. But if this was something like C++, it would seg fault. I don't really need to write an else statement because returning will kind of like cancel that out, so I'm not writing else. What I'll do is I'll say that character occurrences of oh, this is why I messed up, because I put this here. Silly. Okay, that could have been so bad. Actually, I do want a space here. I think my brain just kind of wants that. We're gonna minus equal 1. Okay. Super simple, super easy, and I'm going back. I'm gonna delete that. Why am I having such a hard time with these spaces? We're gonna do for character. We're gonna say for key in character occurrences. So if I remember correctly from the way Python works, whenever you're indexing through a dictionary, so if you're doing like looping through it, what it'll grab you is it'll grab the key for you. So this will give me the key, which will be the characters. So A, B, C, right? That's the key. To get the actual value, you'll do character occurrences key, right? And I hope I got that right in all of them. We'll see if there's an error out. So this will give me the value. So basically, we're going to say that if character thing is not 0 or is not 0, I'm just going to use. Does this? Should use that, not 0, right? That's a problem, right? We're just gonna go ahead and return false, and then we're gonna return true. So this is Oven, this is Oven, and this is Oven. So this is 3 of O of N's. This will probably run poorly for small. Oh, sorry. I guess this is not O of N per se. This is okay. This is O of N. This is O of M, and this is O of the max of N dash M. So yeah, that's okay. Kind of like roughly. It takes the largest one. So the largest value would basically be, whatever this would be. So this would be the max of O of M slash N. So yeah, let's run it, see if it works. If it doesn't work, we're gonna have to figure out why. Hold on, did I spell this wrong or am I tripping? Did I spell that wrong? I did. Let me fix every single character occurrences because I'm a silly guy. It's because I put two C's, yeah. Ah, man. I can't spell. I'm so silly. Oh, already ran it. It feels slow. It's O event, like 3 O events. It's that's okay. I'm in the center of the bell curve. Yeah. Okay. Yeah, so that's 2 that I just did. It's 8:15 now. I think I'm gonna call it here. Let me go back to LeetCode and put a check mark on that. Yeah. So starting off, we just did 2 easies. Obviously, this is gonna ramp up as we get further down the line. Mediums, it's gonna take some more thought. The way this will work eventually, I won't be able to solve these on my own eventually. And so the best way to practice LeetCode is to give up and use a YouTube video. So if you are stuck on like a DP problem for like an hour, at that point you're not gonna figure it out. It's gonna be you staring at that screen for too long. It'll be best to it'll be best to move on, or better, I think, would be to look for the solution, see if you can truly understand it, have someone kind of break it down. I believe NeetCode, he does a pretty good job breaking stuff down for you. Yeah, he has these solution videos here, which is very nice. If not, there's probably solutions of videos you can find anywhere on the internet. So watch a video, have it breaking down. You know, like if it's doing DP for the first time, the chances of you being able to figure it out on your own is very, very low. DP is a challenging concept. So yeah, if that happens, you should look for the solution. And I don't know beyond that. I think like beyond that, me personally, I would look at the solution. Maybe I would program it just to see it run, and then I would delete it. And then I'll try again probably like a week later to see if like I can pick back up from where I was. But yeah, that is for starting off today. Okay. Oh, here you go. Much better. I shouldn't be pulling up Amazon. Yeah, so let's see. We have here, we're on Monday. This is Memorial Day. Happy Memorial Day to everyone. In August 1st. Just whenever stuff starts kind of like hitting the fan. So, yeah, kind of rare. So we have, 1, 2, 3, 4, 5, 6 days this week. 2, 3, 4. That's 28. Oh, wait, what am I doing? I literally just count the last number. Duh. So 36, right? Then 67. 90. Oops. Nope. We don't want to go to August. 67 days. We have 67 days. I will be practicing properly in August, but school starts up around here and it's going to get really hectic, so maybe not be recorded, or maybe it'll be a really small video. We'll see. 6-7 days of like kind of like try-harding it, and then of all the stuff. So that let's see. I did 2 out of 150. I probably want to get all 150 of these done. So that means I'm going to be doing more than 2 per time. And I kind of want to do these hards on their own days, like do like one hard by itself, because like a hard it can get pretty tricky. So I think I'm gonna maybe switch to like explaining less. I think the explaining is good. It's kind of needed for the interview. I'll probably just switch to doing like 3 per video. I have 66 more days, so maybe doing 3 per day. If it's like a bunch of easies, we'll do like 3 to 4 easies. Try to limit the hards. I mean, the hards can really suck. I mean, realistically, you're not going to be doing a hard on your own unless if you unless if you worked with something like that before. So, but yeah, okay, I'm gonna end it here because it's gone on too long. Thank you if you watched, and I'll see you tomorrow.